Okay, the next type of derivative we're going to look at are derivatives of exponential functions. So the derivative of e to the x. So the derivative of e to the x, and this is a strange one, is just e to the x. Now, more specifically, if you have e to some power u, the derivative of e to the u is e to the u times the derivative of whatever the exponent is. And that could be simple or it could be more complicated. Okay? So, for example, if y equals e to the 5x, then y prime equals e to the 5x times the derivative of 5x, which is 5, which we then rewrite as 5e to the 5x. Number 2, f of x equals 4e to the 1 minus 2x. Now, you might think product rule here since e is being raised to the 1 minus 2x, but if you do 1d2 plus 2d1, again, check this out, the second part, derivative of the first term 4, derivative of a constant is just 0, this just goes away. So really it's just 4 times the derivative of e to the 1 minus 2x. So, f prime of x, 4 e to the 1 minus 2x times, what's the derivative of 1 minus 2x? Well, if you think of that, the derivative of 1 minus 2x, so I don't know why I'm writing that down there, is just negative 2. So final answer, negative 8 e to the 1 minus 2x. All right. I'm going to skip 3, let you guys work on 3. Number 4, e to the 3 over x, so the derivative, right, e to the 3 over x times, what's the derivative of 3 over x? Well, 3 over x, same thing as 3x to the negative 1, so the derivative of this, so if y equals 3x to the negative 1, then y prime will be negative 3x to the negative 2, which is negative 3 over x squared. And let's clean this up a little bit. Negative 3 e to the 3 over x squared. I'm going to skip 5. I'll let you guys try 5. Number 6, e to the tan x. Okay, so e to the tan x. Well, that means the derivative is e to the tan x times, well, do we remember what the derivative of tan x is from the day before? We might not. The derivative of tan x is secant squared x. And that's fine. You could look back. It's not a problem. Like I'm assuming you don't have these trig functions memorized yet. The only ones really, sine is cosine, and the derivative of cosine is negative sine. Those are the easiest two, but you might not remember this yet, and that's fine. Just go back and look at it. Now, when you take the derivative of tan x, you also have to take the derivative of what's inside the function here, which is x, which is just times technically 1, but we don't need that. Okay, and you can just leave it like that. That's fine. All right, next up, f of x equals x e to the second minus e to the x. All right, it's a little more complicated here. So let's see, here we have, is this product rule? Not sure. Let's see. I think it is. Minus e to the x. Okay, so, right, 1d2 plus 2d1. When this is 1 and this is 2. So 1 times the derivative of e squared. Well, e squared, derivative of e to the x is e to the x, derivative of e squared is e squared. Plus second. Actually, I'm unsure of that. Let's hold off on that one for now. You can skip 7. I'll post it with the key. go to 8. Oh, sorry. I got it. E squared is just a value. That's why. It's just a number. So it's just like saying, I'm going to rewrite this actually, think of it a little differently. E squared x minus e to the x. And that makes a lot more sense because e squared is just the coefficient. So when you take the derivative, right, imagine 2x, then the derivative is just 2. Same thing here. This is e squared x, so the derivative is just e squared. And then derivative of minus e to the x is e to the x. Number 8. Let's take a look. F of x equals x squared e to the x minus x e to the x. Okay, a couple things here. I was thinking at first, it looks like we're going to have to do product rule. Yeah, unfortunately, I think that's what we're going to have to do. So I'm going to write it over here, 1d2 plus 2d1. This is 1, this is 2. So 1 times derivative of the second plus the second times the derivative of the first minus, and we got to do it again, first times the derivative of the second plus the second times the derivative of the first, which is just 1. So you get x squared e to the x plus e to the x. I'm going to write this as 2x e to the x, and then I'm going to distribute this negative, minus x e to the x minus e to the x. Now notice something, these all have an e to the x term. Could I have just factored up here? Could I have pulled out an x e to the x, and then I would get, let's see, that's x minus 1. I think this might have been easier. Well, not really, it's pretty complicated. What about sine e to the x? So if sine e to the x, you get y prime equals, well, the derivative of sine is cosine. So you get cosine of e to the x times the derivative of the inside, e to the x. So again, derivative of sine e to the x is cosine e to the x times the derivative of the inside. Well, the derivative of e to the x is just e to the x. And then technically you'd have to do it of the exponent as well, but that's just times 1. We don't need that really. We can leave that out. How about some chain rule? So y prime equals 3 parentheses e to the x plus 3 squared times the derivative of the inside, e to the x plus 3 is just e to the x. The 3 doesn't have a derivative, so we could simplify this. 3e to the x times e to the x plus 3 squared. And then number 11, last one, quotient rule. Right? Low d high minus high d low over low squared. So we get low times the derivative of e to the 5x. Well, the derivative of e to the 5x is e to the 5x times 5. E to the 5x times the derivative of the exponent. Minus high times the derivative of the bottom is just 5 all over 5x squared, which if we want to clean that up a little bit, 25x e to the 5x minus 5 e to the 5x over, you could just leave it 5x squared or 25x squared. Cool. So yeah, just complete this lesson and then we will do a mixed practice day Thursday and Friday of the last 3 days.